graders, and welcome to lesson 88 on transformations. So first we got to talk about congruent figures. We've already learned this, but remember that congruent figures have the same shape and size. Similar figures just have the same shape but are different sizes. If something's congruent, they have to be the same shape and the same size. You may have to rotate, flip, or move them first, but one will fit right on top of the other. All right? Now, all of these things we're going to talk about. If we're rotating them, if we're flipping them, which is a reflection, or if we're moving them, which is a translation, all of those are called different types of transformations. So here we've got an example of some F's. First, I'm going to show you with these two paper clips. Let's say that I had one paper clip like that and one paper clip like this. Assuming these paper clips are congruent, I would need to rotate this paper clip, and then I would need to translate it, which means I'm going to move it, and I could make them stand right on top of each other and look like one happy paper clip. Okay, so that is what we're going to be doing. We're going to be thinking about if we need to rotate things, if we need to move them, or if we need to sometimes flip them before we rotate or move them. So for our F, in order to make this F fit on top of this one, I would need to rotate it 90 degrees counterclockwise, and then I would need to reflect it. So that way, if I rotated it 90 degrees, let me draw it here, I would end up with a figure like this, and then I would need to reflect it to be on top of that, and assuming that it was still over here, I would also need to translate it to move it right on top of that. So a translation is sliding a figure in one direction without turning it. If I had this figure and I slid it, it would just move over here like this. A reflection is when I flip a figure over a line like a mirror. So if you picture this dotted line as like a mirror I'm holding up, this is what you would see in the mirror. It's a reflection. The little dots move to this side of the rectangle, whereas up here they stayed on the same left side. A rotation turns a figure about a certain point. So in this case, I just turned it and put it up on its side. If I go this way, then it's like I'm going around a clock. It's clockwise. If I go backwards or this way, it's counterclockwise. If I turn it from this way to this way, that's 90 degrees. If I went all the way and kept going till it was turned into basically a reflection, that would be, in this, at least in this shape's case, if I rotated all the way around like this, that would be 180. If I kept going all the way to here, it'd be 270, but then you might as well just go 90 degrees counterclockwise instead, and all the way around would be 360, which there's no point in doing. So example A, sketch the rotation, sketch the figure after a 90 degrees clockwise rotation. So remember, clockwise means that it's going around this way, it's turning that way. So if I were to turn this figure clockwise, I would end up with a W-looking 3. All right, B says 90 degrees counterclockwise. So that means you're going to go the other way. Go ahead and draw what that would look like. Triangles ABC and XYZ are congruent. That means that A lines up with X, B lines up with Y, and C lines up with Z. Those angles, that A would be congruent to X, B would be congruent to Y, and C would be congruent to Z. Name the transformations that would move triangle ABC to the position of XYZ. Okay, so remember that A and X are congruent angles, and so I need to get this figure to be on top of this figure. I would need to reflect it, and then, since it's all the way over here, I would need to translate it. And I'm going to say translate right because I would need to move it right. All right, try, what about this one? What do you think you'd have to do? I want you to try this one on your own. So notice where the right angle is. So what would have to happen to that? What would have to happen to that figure to get it to be right on top of that one? E, name the transformation that could be used to position triangle A on triangle B. So how can I get A to go on triangle B? Well, I would just need to reflect it. What about, in this case, to get A on B? I would need to translate it. And here, I would need to do two different things. I would need to, I'm not going to tell you. There's two different things you would have to do for this one in order to get them on top of each other. Write down what you think they are. And that's this whole lesson, so go ahead and get to work.